In this video lesson, I will show you how to solve linear equations graphically. Well, first, what do we mean by linear equations? These are not the same as linear functions, but they're pretty similar. Let's write down a few examples just to remember what they are. So a linear equation could be, for example, 2x minus 1 equals 7x plus 8. Or it could be 3x plus 2 equals 2x plus 3. Or, for example, 13x minus 27 equals 18x plus 19. And as a last example, by now you're getting the point for sure. 10x minus 3 equals negative 13x plus 7. So on both sides we have something times x plus or minus something else. Well, you might say we can just solve these algebraically. And that's how we're taught to do it, and usually that's how we will solve them. But sometimes we already have the graph, and the equations actually represent something like cost and revenue functions. So what if we have this graph? So now we have a graph. Well, let's take a look. We have the linear equation negative 5x plus 7 equals 3x minus 1. And on the graph, on the coordinate plane, we have the lines y equals 3x minus 1 on the right, and y equals negative 5x plus 7 on the left. These make two lines, and each function is one side of the linear equation. But how does this tell us the solution? Very simple. It's the intersection point. In this case, we can see that they intersect at 1, 2. So what that tells us is that the solution should be x equals to 1. Well, let's check it out just to make sure, because so far it's unclear why the intersection should be the solution. We plug in 1 on the left side and we get 2. We plug in 1 on the right side and we also get 2. So obviously the solution is x equals 1. And notice that the y value, 2, is what we get when we plug in x equals 1 on both sides. That is why we end up with the same point that both lines intersect. That's because when we plugged in x equals 1, you got y equals 2 for both equations. So they share that point. Now let's take a second example. Negative x plus 5 equals 2x minus 1. Again, we will just start with the graph. So here's the graph. And as before, we have negative x plus 5, the left side of the equation, graphed, and 2x minus 1, the right side of the equation, also graphed. We get two lines, and these two lines intersect at the point 2, 3, because the x-coordinate is 2 and the y-coordinate is 3. So this should tell us that the solution is x equals 2. Let's test. On the left side, we plug in x equals 2 and we get 3. And on the right side, we plug in x equals 2 and we also get 3. So x equals 2 is the solution. And each time we get 3, the y-coordinate of the point of intersection. That is why this intersection method works, is because when we plug in x equals 2, we get y equals 3 from both equations. So both equations are equal to each other. So it's the solution. Now we will move on to our last example. In this last example, we will take 2x plus 7 equals 2x minus 3. So, as before, we will assume that we start with the graph. Well, here's our graph, but where is the intersection point? As before, we have one function, y equals 2x plus 7, is taken from the left-hand side of the linear equation. And the other function is taken to be the right-hand side. Now, the trick is that we have equal slope in both functions, 2. That means that the lines are parallel, which means that there is no intersection point. This means that there is no solution. I hope this video lecture helped you understand the connection between linear functions and solving linear equations. Thank you for watching.